Hello everyone. I think this is the last video on two-column proofs with segments. Let's see what it says. Given M is the midpoint of segment AB. Here's segment AB. And it also says that prove that AB is equal to 2 times AM. Okay? So I have to prove that this segment AB is equal to multiplying this little piece, AM, times 2. And that makes sense. Already in my head, as soon as I read M is the midpoint of segment AB, already I knew that segment AM has the same length as segment MB. I say that segment AM is congruent to segment AB, or that AM is equal to MB. So automatically, by reading the given, already I've concluded in my head, AM is congruent to MB. Okay, so let's write out a plan. I know that M is the midpoint, so automatically I can write that AM is congruent to MB because that's what the definition of midpoint says. It says the midpoint is a point that divides a segment into two congruent parts. So I know this is congruent to this, okay? And I state that by saying this, okay? Now, if two segments are congruent, I can say since I have to prove that something is equal, I have to end up with using numbers, okay, and making them equal. So from congruence, I'm going to move to equal, which is by saying that AM is equal to MB, okay? And how come I can say this? Well, by the definition of congruent segments, okay? If two segments are congruent, then their lengths are equal. So I state that, okay? So far, so good. Now, here's what I'm going to do. Since they're talking about AB, which is the whole thing, AB, equaling 2 times AM, and I have a segment, I'm going to use the segment addition postulate here just to say that AM plus MB is equal to AB because I know I need an equation that has AB in it. So the only way I can end up with an equation that has AB in it is by using the segment addition postulate. So I can state that AB is equal to AM plus MB. Now, look at what happens here in my plan. I know that AM is equal to MB. So do you think I can replace this MB in this equation for AM by the substitution property of equality? Of course I can. So I can rewrite this equation as AB is equal to AM plus, and instead of writing MB, I'm going to replace MB with AM because AM is MB. So AM. And look at this. I ended up with AM plus AM, so I know that AB will be equal to 2 times AM. There's your plan. Now, the thing I did here is not the way it works when we write it over here, okay? This is in my head. This is like fast forward. I have to slow down and make sure I cover every single step that's going on in here when I go and do my proof. So let's go ahead and do that. Let's go step by step in trying to reach this proof statement. As my first statement, I'm going to write my given. M is the midpoint of segment AB. There it is. Okay, and this is given. Given. As my second statement, I can conclude if M is the midpoint of segment AB, then I can conclude that segment AM is congruent to segment MB. Okay? And how did I reach this conclusion? Well, by the definition of midpoint that says that the midpoint is a point that divides a segment into two congruent segments. And that's how come I can write that those two segments are congruent. As my third statement, now I'm done using the midpoint and stating that these are congruent. Now, since I know I need an equal sign somewhere down the line, I'm going to turn these statements into an equality. If the segments are congruent, I can say that their lengths are equal. So AM is equal to MB by the definition of congruent segments. If two segments are congruent, then their lengths are equal. Okay, and I'm done. Now I'm going to go and look at my proof statement, and I notice that I have AB equals something. Now AB is this whole segment. So I know I can write a statement about AB using the segment addition postulate. So I'm going to do that. I'm going to say, hey, AB is equal to AM plus MB. And they're going to ask you, but wait a minute, where did you get that statement from? Well, by the segment addition postulate that says if M is between A and B, then AM plus MB is equal to AB. That's what the segment addition postulate says. So I write that out, and very quickly I notice that I'm very close to reaching the proof statement in my statements column. Watch this. I have AM plus MB. This MB, I'm going to substitute for AM because in statement number 3, it says that AM is the same thing as MB. So if they're equal, I can rewrite statement number 5 and say that AB, let me change colors, AB is equal to AM plus, and instead of writing MB, I'm going to write AM. Okay? And I can do that by the substitution property of equality. There you go. Now we have a couple of more steps. I can't go ahead and just add AM and get 2M. I have to use the distributive property first. Okay, to combine like terms, I'm going to rewrite AB equal to 1 plus 1 times AM. What I did here is, what do these two things have in common? They both have a 1. Okay, 1 AM and 1 AM, and that's how come you can add 1 and 1 and make 2. So we're really looking at the coefficients of these variables. The coefficient here would be 1, the coefficient here would be 1. Those are the common factors. I factor those out using the distributive property. And you might ask, where's the distributive property? Well, if I go back and multiply AM times 1, you get AM. And then AM times the other one, you get the other AM. So we're using the distributive property backwards. We're factoring, okay? And this I can do because of the distributive property of equality, okay? And now that I have an addition of numbers, I can write that AB is equal to 2AM. And this is by simplifying, simplification. I used simplification to add 1 plus 1 to make 2. And there you have it. So in between this step and this step in my plan, I had to do distributive property in between, which is what we do in our heads, but we don't even realize it, that we're adding 1 and 1 to make 2, and then we're keeping AM as our variable. Okay, so there you have it. I hope you understood all these proofs. I'll see you next time.